I am muted.
Okay.
Thank you.
Yep. Let me know when you're unmuted, and I'm going to read this here.
I'm on the line and would like to hear it more louder.
I think we're all set now. Can you hear us now?
Yes.
Okay.
All right, so we're recording this, so if you could just, you're gonna have to. Thank you everyone for coming today in person and on Zoom. I'm Ann Margaret Thomas, the library director here. And I'm so happy that Paul Mayewski has agreed to do this talk for us. I want to first let you all know of his wonderful accomplishments, and I have something I want to share with you, so bear with me. Dr. Paul Andrew Mayewski is an internationally acclaimed glaciologist, climate scientist, polar explorer, and director of the Multidisciplinary Climate Change Institute, and distinguished professor in the School of Earth Sciences, School of Marine Sciences, School of Policy and International Affairs, Business School, and Law School, all at the University of Maine. Paul was born in Scotland, where he was introduced to hiking early in life. He has thus far led more than 60 expeditions to the remotest polar and high elevation reaches of the planet, and has received many prestigious national and international awards, including the inaugural Medal for Excellence in Antarctic Research from a field of 45 countries and all disciplines, and the Explorers Club Lowell Thomas Medal. For his contributions to science, including the discovery of abrupt climate change driven by atmospheric circulation, human impacts on the chemistry of the atmosphere, impacts of climate change on humans and the ecosystem, and for achievements in exploration into uncharted regions of Antarctica, thousands of kilometers of polar traversing, and numerous first ascents of mountains, all to gain scientific knowledge. Paul is the first person to develop and lead prominent multidisciplinary climate research programs at the three poles: Greenland, with 25 US institutions, the International Trans-Antarctic Expedition with 21 countries, and the Himalaya Tibetan Plateau, most recently, the 2019 National Geographic and Rolex Perpetual Planet Mount Everest Expedition. 34 international researchers participated in that. He has more than 500 scientific publications, hundreds of popular and scientific lectures worldwide, 2 popular books, The Ice Chronicles and Journey into Climate. He has appeared on hundreds of media, television shows. The New York and LA Times have featured him. Nova, NPR, BBC, CBS, 60 Minutes, and the Emmy Award-winning Years of Living Dangerously. Please welcome Dr. Paul Andrew Mayewski.
Thank you, Ann. Thank you, and I'll send the check for reading all that in a little while. I don't know how we get rid of this got it. Maybe I do it here, but I. Oops. Can you, anyway, we can get,
If you hit enter, will it go?
if I hit enter, what?
Because got it is,
Just say got it. Yep, click on the
But
there you go.
but my arrow is not getting there
Oh,
because I'm not the host.
you're the co-host, so-
Yeah, but I should be able to.
Who is the host?
And
Oh,
so I'll say again.
Click on got it.
I keep trying to, but I've been trying it for a while and it doesn't do it. All it does is change the,
You have to get out of presenter view.
maybe that's it. Yeah. No, still there.
Okay, I'm changing the host.
Oh, wait a minute here.
No, I can click Now is it working?
Yes, thank you. Thank you. Okay. It's good to have smart people here. Okay. And I can't get rid of the stuff on the top. So thank you so much for coming. This is sort of it's a very different talk than the usual talks I give. It doesn't have any graphs. It doesn't have any technical information. It's all pictures. And the whole purpose of the presentation is to, from a very personal point of view, show you how, as one individual, and there are many others who've done many things in this field, has seen how our view of the world and the way we operate within the world has changed. When I started working in the field in 1968, the theme for everybody, scientists, the public, was that we had to conquer the planet. And you'll see how through a series of opportunities, observations, sometimes observations that took a long time before we figured them out, actually told us that we were in quite a different situation. I entered the field, this field of glaciology, the study of glaciers, because I wanted to go into remote areas. It was as simple as that. And in the beginning, that's pretty much all that pushed me where I went. I'm not the only person who did all of the things that I'll be talking about. They were members of my team, colleagues, and students. We've been funded by a whole series of organizations, primarily the National Science Foundation, which we write proposals for on a regular basis. And I've been very fortunate to have a wife, Lynn, who has been very supportive of all of these travels and leaving the country for long periods of time and missing, unfortunately, some very important things, and also not being around probably when I should have. So 1968, I was in an aircraft, not this one. I was in another one taking a picture, C-130, making my way to Antarctica. It was a dream that I had had for many years, reading National Geographic, going to the American Museum of Natural History. And I got to go because I met a professor in my second year of college who showed a picture of Antarctica. I asked him if he would take me. His answer was no. And then I kept working with him. And eventually, by the time I graduated, we went to Antarctica. This aircraft is flying over the very northernmost part of Antarctica. It's the first place where you see this, these dotted lines. It's a little area called North Victoria Land, which has a lot of prominence as the story continues. We ended up at a place called McMurdo Station, which is a base where we got ourselves provisioned and kept going. But on the way, just before McMurdo Station, you see these magnificent mountains, the Transantarctic Mountains, and you realize that there's absolutely no way that you can guess how high or how far away anything is. There are no human structures in this place that's 1.5 times the size of the United States. And during any particular summer season, it's unlikely that there are more than 200 people wandering around over the ice sheet. Those mountains off in the distance are probably 8,000 feet high. And what you see in the foreground is called grease ice. It's a place where the sea ice is just forming, similar to what's happening today. As you get closer, in the distance, what you see is Mount Erebus, a 15,000-foot volcano, and you'll see a little bit of smoke coming off the top of it. It is continually giving off smoke. It is the only active volcano in Antarctica. As we go into the middle ground, you see a large, flat, floating mass of ice. It's called an ice shelf. This ice shelf, if you saw the full dimension of it, which you can't see here, is probably the size of Texas. If you went to the ice edge, the top of that ice to the water, and remember it's floating ice, so there's a lot of ice below it, but that ice cliff that you see right at the edge is about 400 feet off the water. And the icebergs that you're looking at are easily the size of city blocks. So the scale is absolutely impossible to understand. Not too far from the station, and there's a blow up to the right, is an area that looks very dark. Those are called the ice-free valleys. For a variety of reasons, this is part of the range of Transantarctic Mountains that you can see if you go to the left side of the blue and make your way up a little bit. It's about 1,700 kilometers long, and I spent most of my first 4 years in the Antarctic skiing, sledging, and walking throughout those 1,700 kilometers of mountains. But we went to the Ashrae Valleys first. It was a very popular place at the time. It's popular because for a variety of reasons, the ice sheet, although it's on average about 3,000 meters thick, close to 10,000 feet, the bedrock around these valleys is such that it prevents ice from currently coming in. But there are, however, in the mountain range that surrounds it, these glaciers that come down, and they're called valley glaciers. The valley is quite remarkable. There's obviously nobody in it, except for one person who happens to be me with darker hair and more hair than I have now. And there are rocks like this that are all over the place. It's unbelievable. Now remember, there's a lot of ice, but there's basically no water. The average temperatures here are on the order of 20 degrees, minus 20 degrees Fahrenheit. And these rocks are carved by the wind. And these rocks were what convinced so many of us, including me, that this was an absolutely timeless environment. Something that had basically, you could go back year after year, millennium after millennium, and nothing would look any different. And that's exactly what you think when you see these sculptures all over the place, again, sculptured by the wind. The other thing that convinced many of us, and particularly people who came before me, was finding these juvenile seals. This particular seal walked or crawled the wrong way inland instead of towards the coast, obviously died, and then the wind abraded the upper side of the seal, exposing the bones. If you turn this seal over, you feel it and touch it, it has all of the original fur on it. It feels like a live seal, and it's really quite remarkable. Turns out that this seal is 5,000 years old. It's been lying here exposed in this extremely dry environment, only maybe 5% humidity. So obviously this is a place that never changes, or at least we thought so. A couple of years went by, and then I started leading expeditions into that area in the circle. It's called Northern Victoria Land. We were the first people ever to walk there. We did 3 110-day unsupported traverses in this area. We'd get dropped off by C-130 and then picked up some long distance away. To do this, for the first season, we took our equipment out, went along the sea ice, and that's a glacier terminus that's poked into the ocean, but the ocean is frozen this time of year. And we drove along the edge of this, just a spectacular place to test equipment outside of the station. We went about 40 miles each way. And one of the things that we stopped to look at was Scott's hut from his approach to the pole in 1910, 1911, absolutely preserved as if he had left it. And if you go inside, you see the bunks, you see all of the things that they left behind. They spent at least 2 years here, cutting out pictures from magazines to have something to look at. This is Wilson's laboratory, where he obviously did a lot of experiments. And this is an emperor penguin. They're about 3 feet tall, who has been lying there after being observed by one of the biologists who's been lying there since about 1910 or 1911. And outside, there actually are mummified sled dogs. This is obviously a timeless place. We made our way into Northern Victoria Land. This is before there were no maps. There was no photography that could help you, because in most places it's just flat ice, although there are mountains. And the only way that we did have a theodolite that we used, a sextant that we used. We, however, mostly carried these bamboo poles, because using a sextant in an environment like this is not easy. You need to find a horizon, and if you carry water with you, it freezes. If you use the ice surface, it has undulations in it. You typically carry diesel inside a little plastic box and do shots on that. So we would carry bamboo and put out bamboo stakes, and we'd also like the bamboo stakes because if there was a whiteout where everything turned windy and white, you could find your way around. Everywhere throughout Antarctica, particularly the coastal areas within maybe 200-300 miles inland, are crevasses. This is a very obvious one. This one's probably 20 feet wide, probably 100 feet deep, and it probably has several bridges in it. If you go through this, if you're fortunate, you'll hit the next bridge. In leading these traverses, I went through hundreds of miles of these things. When we got close to them, we would get off the snowmobile and go and probe our way through. Some of them you couldn't see at all. And as we got into interior portions in later years, Some of the crevasses were so large that they would easily swallow a tractor, a large tractor with a large sled behind it. Camping, I've spent close to 5 years living in one of these tents in polar regions. For camping, we used basically the same tents that Scott used. We just ended up having a better end to us. And we had 2 snowmobiles. Each one would drag a sled. These are called Nansen sleds. And these tents are made of Egyptian cotton. They're terrible in wet weather, but we don't get wet weather here. And but they're remarkable in strong winds. They're double walled. They have no way of heating on the inside other than when you're cooking meals, and you can't have the stove going any longer than cooking a meal because of carbon monoxide poisoning, which in fact we have experienced. As you get to onto some of the high snow plateaus and look off in the distance, right in the center of the screen is that very steep cliff. That's 5,000 feet of relief right there. So we started moving around a lot, and particularly looking at these smaller glaciers that come out of the mountains, similar to the way they did in the Ashrae Valleys. As we got closer to them, we realized that there were former positions marked by these bumps or moraines. And as we looked at them, the moraines, we realized the material was very fresh. This was our first indication that sometime within the last few hundred years, maybe even more recently, glaciers actually began to recede in the Antarctic. Maybe it wasn't as timeless as we thought it was. As we continued on our traverses, we carried tents with us. Each year we started with new Scott tents. Notice a little stovepipe on the top. There's no floor in these things. You dig a trench in the middle. It's for 2 people, 1 on each side of the trench. The trench is for cold air to sink into. This particular picture, the temperature is probably minus 25 degrees Fahrenheit. And it looks as if the people in there are very comfortable. In fact, they are. After you've spent at least a month in the field and haven't washed the entire time, and you're so used to it, you've never been in a warm place except an occasional mealtime, you get quite used to it. But most importantly is the color of the forward tent. We had just replaced one that looked like it and put up the slightly more orange one. And we started to think to ourselves, why in the world, within literally 30 to 50 days, are these tents becoming so sun bleached? Well, as it turns out, let me go back, sorry. As it turns out, we found out 10 years later that we were there in the beginning of the Antarctic ozone hole, a time when the ozone that normally protects us from incoming radiation was basically gone during a few weeks of the year, which is when we were there. And so the radiation beaming down on these things was enough to not only make them light colored, but if we left them up much longer than that, it looked as if there was a cat scratching them and just ripping the material to pieces. So after several seasons in the Antarctic, and I continued to go for many more years and still do, I started to think that this was an amazing place to work, but yeah, basically it's timeless. People think that it's basically another planet. And I started to get more interested in what could we do with glaciers. And of course, the place to go where people might benefit from an understanding of glaciers, particularly thinking that the polar regions had nothing to do with us, is the Himalayas. Himalayas have more than 10,000 glaciers. This is an image, obviously, from a spacecraft. And to the right is the Tibetan Plateau, very dusty and windy. And to the left is the Indo-Gangetic Plain, India, Nepal, all of the fertile areas. And of course, once you go into the Himalayas, you encounter a lot of people. These people are dramatically impacted by how much water comes during the monsoon season. They're dramatically impacted by the health of the glaciers because that's where the water is stored and then melts during the dry season. And they live, in some cases, in very extreme conditions. But where do you go in the Himalayas? Nobody had ever drilled or worked, did the things that we do, which was ice coring, which I'll talk about in a few minutes in a bit more detail. So I started reading books, and I came across Fanny Bullock Workman's work. You can see her second to the left from the right, and she's a very famous climber from the turn of the last century. She did a whole series of first ascents. This particular one is of Nun Kun. I knew where Nun Kun was on a map, but as it turns out, you cannot go at that time, and I think even anymore, we couldn't go to India and actually have a map in our possession because it was considered to be a security breach. So we were basically checked out, no maps, no aerial photography, and I'll show you what the aerial photography looks like. It wouldn't have been any use anyway, and absolutely no form of communication was allowed. So we would go off for 2 or 3 months and then turn back up again one day, having gone through the mountains. This is an aerial photograph centered on the Nung Kun Plateau, one of the few that I could find, and I certainly could identify the glacier, but I couldn't identify anything about the top because it's cloud covered. So we had nothing to go on. We rented a truck, loaded all our equipment in, 6 of us, started making our way northward. This is through some of the typical restaurant area on the way in the Punjab, made our way into Kashmir, and this is the city of Srinagar and Dal Lake, and in Kashmir, as I mentioned, along these very treacherous mountain roads, typically 1 lane at best, with tremendous amount of debris falling off. Eventually over the Suru Valley, crossing over the Suru Pass and the Suru Valley. These are basically oxen, water buffalo. And as you get to the other side, all of a sudden it gets significantly more arid. Along the way, however, we noticed that there were a lot of friendly faces. As you can see, the Ayatollah Khomeini was far more popular in the area than we were. And eventually we got to the last little village on our way to Nung Kun, this area that Fanny Bullock Workman had identified and that we saw in the picture, and that looked like a good place to work. This was the hotel. It had just opened a couple of days earlier, and we spent a couple of days here. When we approached this village, we were on the suburbs. We came in and we found from a distance, we could see these people sitting on what turns out to be their house. And in fact, they were so unused to seeing foreigners. The area was only open about 4 months a year. They were so unused to seeing foreigners that what they would do is send a small child out to see us, because if we were dangerous, that was an acceptable loss, I think, to them. We weren't dangerous. We took a lot of pictures of them. We had presents for them, and we made friends. So as it turned out, I naively thought that these people would know how to take us to the place that we wanted to go, which was about 20,000 feet up. But as time went on, and this was only my 2nd season in the Himalayas, I realized these people spend all of their time trying to survive where they live, growing crops, having livestock, keeping themselves warm. But I did manage to get a group of them together who would be willing to help us carry some loads. We all carried the same weight, usually about 60 pounds each, as we made our way into the mountains. And the closer we got to what I thought was Nung Kun, the more debates there were between all of us about which direction we should go. We didn't have a map. We couldn't speak the same language. So every now and then, a few of them would go off in one direction away from the rest of us. I'd have to send somebody with them to make sure that the gear that they were taking along actually came back with us eventually. And as time went on, we did in fact see Nung Kun. And Nung Kun is that plateau and the peak that you see in the top of the picture. And these are a few members of our team, the local people, the local Ladakhis, many of whom had fled Afghanistan during the Soviet-Afghan War. And we encountered these 3 ice falls. Now, ice falls are dangerous enough to get up on without not knowing really where you are and what was at the top and how to get around them. So it took us a few days to figure out how to get up these ice falls. Each one of them, and you can see there are 3, is 500 feet high. We had to get all the loads up, and in the middle of the day, the temperatures would get so warm that the ice falls would start to move, and there would be quite a few avalanches. And you can see that's a person in the sort of the lower part, that dark spot. And you can see these slabs of snow and ice. Those are from a recent avalanche that had just come down. And we put in screws for the ropes to help everybody pull themselves up with the loads. And we'd have to go down every single day and reset the screws on these 3 500-foot ice falls. So at one point, about 2/3 of the way up the ice fall, we go off to the side, stay on the bedrock for a while, set up camp. But the camp was, and we left those tents there for a while for the period that we were taking equipment up and down. And those tents were not to spend the night. Those tents were to get out of the sun. In the middle of the day, with all of the reflection off the snow, the sun temperatures were 110 to 120 degrees Fahrenheit. So it's about all you could do to walk around. And added to that, this is well above 10,000 feet, getting close to 20,000 feet. And at 20,000 feet, you have about half of the oxygen that you have at sea level. So wearing all these masks, you get a little bit of a feeling for what it's like to walk at climb at high altitude.
Well,
Yes.
because somebody's been waiting to get in for a while.
Oh, okay.
Click on the blue
I
button.
had to make you the,
Sorry to
Thanks.
interrupt.
Thank
you.
I've been waiting for quite a while.
yeah, so I don't know, since I'm gonna make me the host and switch back and forth for a minute.
Okay, sure.
What year is this, Paul?
This is 1980.
Okay.
As we got higher up, and I'll show you some pictures from higher up, at night, we noticed something very interesting to the west. We were at 20,000 feet. It was pitch black, amazing views of stars, and we'd see sparks every now and then. Remember, we're in Kashmir, and between Afghanistan and Kashmir is Pakistan. And we're convinced that we were seeing artillery fire brightening up the sky from the battles in Afghanistan at the same time. But we were safely up at 20,000 feet. Nobody was going to be shooting at us, obviously. Okay, great, thank you. So as we got up to the last, up over the last ice fall, we saw something that was very important to us. In the lower right, you see those debris bands, those dark bands. That's critically important if you want to drill an ice core, because those bands are dust and they come in during the winter from the Tibetan Plateau. And then the cleaner looking snow is the precipitation that comes in from the south off the ocean and brings other things with it. So this was a very important finding for us. And then we eventually got up to the top of the Nunkun Plateau, and we have views like this. This particular one is looking southward into the Indo-Gangetic Plain after you get through all of these glaciers. On top of this plateau at close to 20,000 feet, we spent a few days there. Actually, we spent 3 weeks there. It had taken us 6 weeks from the time we left the States to get to the site that we wanted to work. So when we were up there, we noticed something very interesting. We noticed that there were clouds coming from the north and clouds coming from the south. In this case, the north is to the left, that's the Tibetan Plateau. And the clouds coming from the south were coming from the Indo-Gangetic Plain. So we were seeing snow that was being deposited from 2 completely different sources. And if you look at the map, the red arrows going north-south are the winds coming off the Tibetan Plateau, most likely during winter and spring. And then to the left are air masses coming from the west. But most importantly, the air masses coming off the Bay of Bengal and the Indian Ocean are the ones that bring moisture in. And this is called the Indian Monsoon. This controls the economy, the lifestyle, the existence of the people in this entire area. So this was the big goal. Could we drill an ice core and go back year by year? We could see the years, but could we do something that would actually allow us to understand when we were seeing Tibetan cold winter versus the other? Well, the answer actually came to us because what we did was, you can see there's fresh snow under my feet there. We went from 20,000 feet down to 10,000 feet one day, collected fresh snow after the snowfall finished, came back up to the camp, kept those samples, and we made the assumption that there must be some kind of a fingerprint, a chemical fingerprint in the snow that would allow us to tell the difference. And today, or not today, but by early 2000s, this is a NASA animation of satellite imagery. It's being all put together. This is real satellite data. The only thing that they did was to colorize the clouds. So if you look in the center, the orange air mass that's moving basically from east to west, that's Saharan dust getting into the southeastern United States. On occasion, it even gets into the Amazon because it has a lot of iron. It fertilizes the Amazon. The green that you see are air masses. Again, this is colorized. but for this purpose, the green air masses are biomass burning. If you go to the south around Antarctica, you see those swirls. Those are sea salt incorporated, and that sea salt tells us how strong the pressure systems are. And if you go to the north, you'll see a little bit of blue. That's the Icelandic low up there that brings in our nor'easters. And you'll also see some white, and that's pollution that's coming off North America and Eurasia, particularly things like acid rain. So we were able to develop for ourselves a chemical marker, and the chemical marker basically looks like this. If you drill in an ice sheet to the left, or an alpine glacier, high alpine glacier to the right, and you look at all of these chemistries, you can tell things about the strength of ocean, air masses over the ocean. You can tell past temperature. You can tell changes in the energy of the sun. You can see whether there's agricultural activity, whether or not the deserts are expansive and drying, and if air masses went over them. Volcanic activity, industrial activity, mining activity, forestry, biological productivity on land, biological productivity in the ocean, sea ice extent as if you go into the high latitudes, on and on. So what we did and have been doing for the last 50 plus years is to recover ice cores, which layer by layer, year by year, and now we're down to storm by storm, can take us back hundreds and thousands of years from all of these little dots to reconstruct past atmospheric circulation. And the atmosphere is important because the atmosphere transports heat, moisture, pollutants, it changes surface ocean currents, it does a whole variety of things. So I'm going to use this image from here on just to take you to different parts of the world where we've been working. This one focuses on Greenland. You can see which way the air masses are moving. You can see that you can actually get a signal from primarily North America, but also in some cases from Europe. And we were particularly, this is the mid-1980s, we were particularly interested in seeing whether we could prove that acid rain was caused by humans. It sounds familiar, doesn't it? The same debate that went on until a few years ago about whether or not warming is because of humans. And of course, there were the same battles between scientists and skeptics. And we claimed that if we drilled through the Greenland ice sheet, we could actually find a record of the two precursors or the two components of acid rain, which is sulfuric acid and nitric acid. To do this, we had to use solar drilling systems because we couldn't have a gas or diesel powered engine powering this drill. We went back to the year 1750 with this. We analyzed for the first time ever for this chemistry. And what we were able to demonstrate was that the increase in acid rain, in particular sulfur, starts about 1900. We could identify major volcanic events because they give off sulfur too, that the sulfur drops down a little bit during the depression, increases tremendously after the depression, and then continues to increase right into the late 1970s and 1980s. And then the best thing of all, when we went back and re-drilled this not that long ago, we could find out that the Clean Air Act actually worked, that the sulfur levels reduced. Nitrate's more complicated. It comes from automobile emissions. And although the emissions have been reduced, it hasn't necessarily changed that much in this part of the world. So this was the first indication that we could not only track air masses, but we could also take a look and see how humans have impacted the chemistry of the atmosphere. We continued in Greenland doing a series of traverses, snowmobiles, and also these really cushy tractors and bigger tents. We went all over North Greenland, Central Greenland, South Greenland. And the purpose was to find that red star, which is a place where we could drill an ice core in the deepest part of Greenland, which turned out to be a little bit over 10,000 feet. It took us 5 summers, close to 20 months in the field. We built all of these things. We built the dome for the drill. That's the drill tower. We built all of the living areas, scientists and all of the logistics people together. And this is the inside of the drill area. We had very close friends we'd worked with in other parts of the world. This is the ice that came out. I was fortunate enough to be the leader of the 25 institutions that were involved in this project. It was the largest such project ever funded by the National Science Foundation. We had a lab that we excavated by hand ourselves, a freezer, basically a built-in freezer place. The surface temperatures were about 20 degrees Fahrenheit, minus 20 degrees Fahrenheit. but even so, it wasn't quite cold enough. We cut the ice up. It went off to 25 different institutions, a whole set of many different sets, and now hundreds and hundreds of peer-reviewed scientific papers. And this is the day that we hit bedrock. We drilled right into the bedrock. And the question is, what did we learn for all of this? Well, as it turns out, because we had the first annular resolved continuous record of the last 110,000 years, we learned how the climate system operates, the influence of our position relative to the sun, the influence of volcanic activity, solar activity, and the beginning of, this is 1993, the beginning of the realization that things were really changing in terms of greenhouse gases, and most definitely had changed with respect to a variety of other toxic substances. We learned a lot of other things, and I won't go into much more detail except to show you this, because I said it would talk about civilization. We learned that, in fact, there were very interesting events. These are called abrupt climate change events. And these events are massive shifts in temperature, precipitation, and storminess that occur in less than 2 to 5 years. And once they occur, they shift the climate system into an entirely new state. So you can go from very stormy within a couple of years to less stormy. They're controlled by how much sea ice exists in the North Atlantic and a variety of other things, which is another talk. But the meat here is that these abrupt climate change events, as we started to look at them, we found that they correlated perfectly. Remember, we could count back year by year like a tree ring. We found that they correlated perfectly with the disruption of major civilizations. 4,200 years ago, there was a very dry period, which meant not much sea ice in the North Atlantic in what is modern day Syria and Iraq, and the entire Mesopotamian culture in that region disappeared within a couple of years. If you don't have water, you can't have a civilization. That's also, again, where modern day Syria and Iraq is, and there are many of us who believe that much of the underpinning for the wars in the Middle East obviously came because of drought. 900 AD, plus or minus a couple of years, is one of the 3 major collapses of the Mayan Empire. The other 2 are also related to abrupt climate change events. 1000 AD, the North Atlantic was relatively warm, not so much sea ice, not as warm as now, but it was warm enough for the Norse to go from Iceland, this is Eric the Red, to Greenland. They colonized Greenland. In the lower right, you'll see that they built cathedrals, which you can obviously still see today. They had farmsteads, they raised sheep, but they needed yearly resupplies. And around 1400, within a matter of 5 years, the sea ice suddenly locked the area in. The resupply ships from Scandinavia couldn't get in, and the people starved, and they never adopted any of the Inuit ways of life. So we discovered this in 1993. It took until 2004. Well, we made the newspapers for a couple of years. There was a lot of interest in it, but the first group, other than the media, the newspapers, which eventually died out, that got interested in it was Hollywood in 2004. And the Day After Tomorrow is based on the findings of these abrupt climate change findings. They got the speed of this event right, but of course they didn't quite get the direction of the temperature. New York City it becomes covered with snow and ice in a very short period of time, and quite the opposite is happening. But they certainly get all the credit for being the first group outside of the scientific community to really understand this. Shortly after, the Pentagon realized that this was very important, because obviously it creates immense disruption for refugees, geopolitically, et cetera. Bringing us up to today, this is the only scientific plot on here. Between 2007 and 2012, in particular in the Eastern Arctic, we experienced the first abrupt climate change of the modern era. And that first abrupt climate change is directly related to the massive losses of sea ice, triggered by greenhouse gas warming, and accelerated, doubled literally, by the fact that once you remove sea ice, you have an open ocean which gives off heat. You have an open ocean that's dark that absorbs heat versus sea ice and snow, which is very cold. And this is the beginning of the major disruption to the weather systems that we experience right now. The fact that the Arctic has for thousands of years, hundreds of thousands of years, been very, very cold and ice covered. And now we have a new ocean. Certainly compared to the last 110,000 years, an absolutely new ocean has appeared. It changes the temperature difference between the Arctic and the mid latitudes, and that changes the wind patterns. And when you change the wind patterns, that allows cold air to move much farther south because the barrier actually weakens, warm air to go much farther north. And there are certain times in the middle of winter now, starting as about 2014, when the North Pole is actually above freezing in the middle of winter and the middle of darkness, all because of this dramatic, abrupt climate change and sea ice. So now let's move to the Southern Hemisphere. Started going back to this, well, we were always going there, but we had discovered this interesting thing about acid rain. We wanted to find out what is the natural level of chemistry in the atmosphere. So where would you go? You'd go to the most remote part of the world, the interior portion of Antarctica. You would go there on a snowmobile. After you get dropped off by C-130, you might go 500 miles away. And then after 500 miles, you continue to walk right into the coldest dome area of that region, skiing. And then when you eventually get to where you want to sample, and this is only a little surface sample, you put on all of these clothes because you haven't washed in 2 months, and you wear plastic gloves, and you take a snow sample to in fact see whether, and also drill an ice core to see, does the contamination in the Antarctic, this very remote place, look anything like the contamination in the Arctic? And one of the places we worked was about 200 miles outside of the South Pole. The temperature, although it doesn't look like it, we hopped out to do the picture, was minus 50 degrees Fahrenheit. Again, still living in a Scott tent with no heat. And we dug a pit, snow pit, which went down 15 feet. We sampled, I should do it in meters. It went down 6 meters actually. And we sampled every single centimeter all the way down with these thin gloves on it at minus 50 degrees centigrade, not Fahrenheit, minus 50 degrees centigrade, in order to see whether or not, because the snow layers, the annual layers of this region are very thin, to see whether or not there's any change. And the record went back just in that 6-meter pit about 50 years, and we discovered some very interesting things. But the most important thing we discovered was evidence of the radioactive dispersal from the Chernobyl nuclear power plant, which exploded or had the accident at 60 degrees north latitude. And there was always a big question whether or not something emitted in the Northern Hemisphere could make its way to the South Pole. And the answer is, if it's in the right part of the Northern Hemisphere, which this happened to be, it can get high enough in the atmosphere. The other thing we were able to demonstrate was how long it would take a radioactive particle or any particle, anything transported, to go from that area to the South Pole or close to the South Pole. And it had always been estimated based on models that it would be about 18 months. And that's pretty much exactly what we found by counting the layers in the snow. So Antarctica, all of a sudden, the chemistry and the atmospheric circulation patterns, we had much better tools. And of course, Antarctica is a giant place, 1.5 times the size of the United States. If it were to melt, sea level would rise. It will not melt completely, but if it were to, it would raise sea level 60 meters. It has 90% of all of the fresh water on the planet. It has the most biologically productive oceans and coastal, well, oceans only, in the world. This is where, if not now, in the near future, most of our marine fisheries will probably be supplying the world. And it's also the place, that's sort of a sloppy diagram, but it's also the place where the cold water that melts off Antarctica sinks and actually drives a lot of ocean circulation throughout the rest of the world. It's a big problem with Antarctica, though. If you look at the dots, these are dots showing you where there are instrumental records, where people are recording, sometimes spot recordings in the ocean, sometimes stations. Obviously, Europe and the United States have a really great array of temperature. But if you look at the dots around Antarctica, there's almost no information. So how do you go back and how do you reconstruct what the temperature was like? Well, obviously from ice cores. Antarctica is a big place. It took a while to convince the National Science Foundation that one ice core wasn't going to tell us about everything. So Lynn and I had spent a year in sabbatical in France, and I came up with an idea, and I asked her to sketch it for me. And this is a tractor traverse in Antarctica. It's called ITAS, the International Trans-Antarctic Scientific Expedition. We got occasional airdrops of fuel. We would burn fuel and replace the fuel with ice cores. There were up to about 15 people working on this. We traveled thousands and thousands of kilometers. And here's what the actual system looked like. So Lynn's sketch wasn't so bad. She realized pretty much what we were going to be using. All of the red lines are the places we traveled. Again, thousands and thousands of kilometers. The suit that I'm wearing, the lower part of the suit, that orange part, is made out of exactly the same material Scott tents are made out of, Egyptian cotton, the best windbreaker in the world. Moving along across Antarctica through thousands and thousands of kilometers, you have to worry about crevasses. If one of the vehicles even tilts in part way, that's probably the end of the show. We did this for 8 or 9 seasons. And the only way we knew if there was a crevasse in front of us, because with all of the windblown snow, you can't always see the edges of the crevasses, was to have out about 30 feet in front of us, there was an inner tube. And the inner tube could actually send back a signal which would tell us whether or not, it was basically an ice penetrating radar. It could tell us whether or not there was something possibly strange happening. So one person would drive, the other person had to look at the screen constantly, moving at a speed of about 3 miles an hour. You could outrun these vehicles. And it went on for hour after hour, 24 hours a day. We would keep driving until we found a place to work. We had probably 30 to 50 feet to stop close to 100,000 pounds of equipment before going into a crevasse, which we never did. We did a lot of repairs along the way. Those boxes we collected ice cores, so we would offload fuel drums and take on ice cores. We had solar panels for some of the work we did. We had people from all over, all an American program, but we had several national flags up there. If you look at the little triangular structure on the sled in the upper right, that's the traveling pooper. Normally, we don't have something like that, but because we didn't necessarily have the time to set up camps along the way, and the living shelters were just not suitable for having a toilet in, we would go and dig a hole, so to stop that thing, dig a hole and on our way. There were some, in general, the weather was quite remarkable for all the months that we were doing this, but there were times when the snow really kicked up. And when it really did kick up, the tractors, and this is a big tractor, Caterpillar, would get at least half covered. So it would take many hours again to dig out the tractor and all of the sleds. And the tractors were really good if it was flat terrain. But if it wasn't flat terrain, if there was much of a slope, we'd have to take one sled at a time and shuttle them. We collected ice cores along the way. Again, this is super cold. You can see what the ice core looks like as it comes out of the drill barrel. We set up little laboratories every now and then, hand dug, to do some basic studies on the ice cores. You couldn't do them inside the traveling shelters, even though they weren't warm. They were too warm for this. And the big thing that we discovered from ITAS was, number one, that Antarctica was changing. This is 21 countries all together working. And we like to call this the sleeping giants are awakening. The coastal areas were losing sea ice. The glacier terminuses were beginning to deteriorate as they came in contact with the ocean. And the other thing that we were able to demonstrate was that Antarctica was more polluted than we thought. It's still pretty pristine compared to the rest of the planet, but we found evidence in the Antarctic Peninsula of uranium. And you can see the arrow starts in Australia, where there's the second largest open pit uranium mine in the world, makes its way all the way into Antarctica. We saw copper coming from the copper mining in Chile, and as I already mentioned, we saw evidence of Chernobyl. Next place was back to Asia. We've been working there off and on, but this was a much more concerted effort. There was a lot more interest in water availability, the quality of the water. And we worked all over various parts of the Tibetan Plateau, the Nepalese Himalayas, the Indian Himalayas. But of course, the iconic place is Everest. which has three names: Chomolungma for the Chinese, Sagarmatha for the Nepalese, and Everest for Westerners. And it's inside that circle area. There are two approaches. You either march up the Kumbu Glacier to come from the Tibetan side, or you march up the Kumbu Glacier to come from the Nepalese side. In the mid-90s, I was always looking for opportunities to have Lynn come along, and Lynn and I flew into this airport, the shortest runway in the world, Lukla Airport. Basically, you fly as you take off. It's a very short runway. You just basically go off the cliff as fast as you can. There are aircraft down on the slopes that didn't make it. And when you come in, you put the brakes on and reverse the engines, because right where that person standing in the lower right is a stone wall to make sure that you stop. And from there, you hike up these remarkable valleys with, there's no rhododendron here, but there are rhododendron trees, beautiful little valleys, all of these tiled slopes where people have crops. And eventually you have to go across a bridge. Now, when Lynn and I first went in the mid-90s, if you look careful, you'll see yaks crossing the bridge. These bridges are no more than about 3 feet wide, and I promised I wouldn't show Lynn on the bridge, but Lynn is quite amazing. When she came to New Zealand with me years before this and saw a bridge like this, she refused, and we just went back to the hotel. And I said, well, we'll probably see one of these in the Himalayas, and she forgot about it. And we encountered one, and she made her way back and forth across about 10 of these, and we eventually got to the south side of Everest. There's a stupa in the background, and that's the two of us in 1995. Yeah, Lynn did an amazing job. So then we started working on the north side. I started collaborating as of 1989. My first collaboration with the Chinese on my way out. I was in Beijing during Tiananmen Square. I'm sort of like Forrest Gump in some ways. This is the Rongbuk Monastery. Just before you get to the base camp, which is at about 15,000 feet for the ascent on the north side of Everest. Before this, you would have landed in Lhasa. This is the Potala, where the Dalai Lama lives, or lived until the Chinese takeover. The series of monasteries along the way, some of them still have a few monks. The Chinese fellow, who's a very close friend of mine, almost like a brother, he has done very, very well collaborating and working with the Tibetans. So we were actually able to spend many nights on the way inside these monasteries, which was an experience by itself. And then we eventually drilled at close to 7,000 meters. We spent 3 weeks up here. I think it's 6,800 meters. These are the Chinese drillers on it. And this group happened to be on the night shift. The fellow on the left is a postdoc of mine, and we've worked together in many places. We've been in a pretty horrific car accident together in Tibet, and still work together in many other places. So next place, there are other mountains in the world. Next place to go was Patagonia. The way you get around in Patagonia, unless you've got a pile of money, is to go on a fishing boat, get dropped along the shore. This is what's called the Cordillera Darwin up in the left. It's a very high mountain. It's pretty treacherous to get much equipment up, so we actually did have to hire a helicopter. So we hired the helicopter not to transport everything into the field, but to come to the beach where we had gotten off the fishing boat, and to then give us quick hops. It took about 10 minutes to get up onto the plateau from the beach. It looked beautiful the day we left. By the time we landed, it looked like this. We were on a plateau at about 12 or 13,000 feet. I was told that the weather could really be bad here, and we should be prepared. So I brought 3 months of food because people do get trapped in these places for 3 months. We were trapped here for 17 days in 100+ mile-per-hour winds, trying to figure out. We had 3 tents. The first one was destroyed immediately. And then we had these 2 little tents. There were 2 of us in each tent, so 4 people. One person had to be awake all the time to make sure that the snow drifts were not getting so high that we'd be sleeping in our own CO2, to make sure that if there was a tiny hole forming in the tent, you'd stay inside and sew the tent up. Going outside to the bathroom was a real treat. And we got, as I said, caught up there for 17 days. This is the helicopter that took us up. and there was supposedly a slight break in the storm, which did in fact last 2 months. We were lucky we got out when we did. And this pilot in the center came up, threw everybody else out of the aircraft to his crew, threw all the seats out except for the 2 seats in the front, got rid of everything he could, flew up, basically crash landed at our site, picked us up. I had to leave all of our equipment. We lost $100,000 worth of equipment, and then come back down. It only took 15 minutes to come down, or 10 minutes. And then he had to leave, and he couldn't take us with him, not because there were too many of us, but because he had extended the transmission and the engine on the helicopter, so he couldn't take passengers. Nobody really knew where we were. Turns out that the fisherman who dropped us off couldn't pick us up. He did give the coordinates, but in fact, it took 3 days for us to get picked up. We didn't have any food. We had garbage bags to sleep in, but it was much better than being up in the middle of that 100-mile-per-hour wind. So then we moved farther north into Chile, and this is the camp up in one of the sites in the Andes. I'll show you this very quick video. Well, it's a 2-minute video, and then there's not too much more after this. This is pretty interesting because this is a relatively easy site to get to, but it was an exciting site. The men who are here are called arrieros. They're Chilean cowboys, amazingly tough. They are typically part Mapuche, which are the local indigenous people, and mixed with Spaniards. And they know this area inside out. As you can see, there are some trails. It's a protected area, so we didn't bump into any other people. We were eventually going to climb up to about 19,000, we did climb up to about 19,000 feet. And there's a stream down there, which is the only place we use the horses who are normally carrying the loads, because the stream could be deep enough that in fact there's no way you can walk across. Then we just continue climbing. We had several camps. This is 2011. 2010, we were up at one of the high camps, and that was during the 8.8 class earthquake that happened in Chile. We were shifted in our tents at about 4 in the morning, back and forth several feet. We drilled in an active volcano. These are the fumaroles coming out of the outside. Sorry, not an active volcano. Well, it is active. It still has the fumaroles, but where we were drilling was the old interior of the volcano, where there was about 100 meters of ice. You can see we're getting higher and higher. This is the end of where the horses can go. We set up the camps. Just a beautiful place. The only thing that wasn't so nice about it was the fact that if the wind changed direction, you got all of the sulfur smell from the fumaroles, which when you already have half of the oxygen at sea level. This is the radar group going across to figure out what the ice thickness is, help us determine where to drill. This is our initial reconnaissance lightweight drilling system. It's solar powered. You can see the drill coming up, and I think the ice core will come out. And then we clean the outside. In this case, we didn't bring the ice core back. We actually cleaned the samples and brought them back as melted samples. So, whoops, no, we don't want to do that. So now let's go to the Southern Ocean very quickly. And this is our form of transport in the Southern Ocean. Skip Novak is probably the most famous blue water sailor in the world. This is his purpose-designed second vessel, Pelagic Australis, which he just sold to Greenpeace. There's an older one that he still owns that works in the Arctic. And we have, over the 4 seasons that we've sailed with him, done about 4,000 miles in the Southern Ocean. And many of you are far better sailors than I am. I found it to be an amazing experience, but I'm glad I didn't have anything responsible to do with where we were going or how we used the sails. But it's a remarkable vessel. It has a sea door on it, so that in fact, if the vessel does flip and you get demasted and you're inside, you're basically in a lifeboat. We were knocked down twice with 60-knot winds, with almost all the reefs in, and it came out of nowhere, absolutely nowhere. This is what it looks like on a fairly calm day. This is my very dear friend in Chile, Gino Casasa, and that's Skip Novak. at the wheel. Everybody works on this vessel. There are 3 crew and there were 4 of us. So we all did the shifts. Everybody cooks, everybody cleans, exactly the same way we work all over the rest of the world. Amazing views. These are penguins on an iceberg, just remarkable. Killer whales, leopard seals, all sorts of wildlife. And our goal on one of the trips was where that red arrow is going in. That's King Haakon Bay. That's where Shackleton in his open boat made his landing. And eventually those red lines, one of them, the one that is the more northern one, I believe is the one that he took to make his way to Stromness and eventually to a whaling station. This is after basically having his vessel and everybody with him frozen in. He didn't lose anybody. This is what it looks like sailing into King Haakon Bay with Pelagic Australis. We have a Zodiac. The weather was pretty calm. We've worked in some places where you have to, particularly in the South Sandwich Islands, where you have to wear a dry suit and jump out of the Zodiac because the waves are too big, swim to shore, and then grab a rope and pull yourself back onto the Zodiac. And then we did the entire Shackleton traverse under much less harsh conditions, obviously, than Shackleton. We had food, we had good shelter, and we were having a great time sledging up on the plateau. And then next, I jumped to Everest. This is getting close to the end. In 2018, I was approached by National Geographic and Rolex to lead the Everest expedition and to be the science leader. Our goal was to have a summit team, not me. I'm too old now I've been up at very high altitude, but I'm too old to go to the top. My job was to be at about 20,000 feet helping direct what went up and what happened at camp and what went on lower down. And our goal was to put up is to drill the highest ice core in the world, the summit team, and to put in the highest automatic weather stations in the world. And this is a view, actually, we got a little bit more detail in a second. You start in Kathmandu, absolutely marvelous, marvelous city. Lynn and I have spent quite a bit of time there. It's a beautiful place. You go through these remarkable valleys. Nowadays, you either take that Twin Otter flight that Lynn and I took, or you took a helicopter. In '95, there was almost no aircraft that could land up around the Everest area. Today, there are helicopters coming in during the climbing season, several a day. You go through Namche Bazar, which is one of the most famous crossroads in the silk trade. It has, when we first went there, even in '95, there were a couple of hotels there. They're not fancy, but they're really beautiful tea houses. Nowadays, this town has the greatest collection of high-end sporting equipment stores in the world. I've never seen such beautiful equipment, things that we don't even see in the US because they're only sold in Asia or in Europe. And it's a tourist mecca, but it's also the place where you continue to climb up to the south side of base camp. That's a stupa. And those slabs that you see of rock, those all have prayers carved on them. You always go to around any of these cultural features, you always go to the left. As you continue higher and higher, you see all of these cairns, but this particular set of cairns commemorate all of the people who died on Everest, on both sides of Everest. I think it's up to 300 or 400 now. Yaks, it was a high finance expedition. A lot came in by helicopter, but a lot came in by yaks. The yaks carry about 50, 60 pounds. The people are very, very good to them. They don't want to push them too hard. And then we had some porters who helped us too. They carry about the same amount actually, and make much less. And what you're looking down on right now, if you concentrate and you see blue and yellow and orange, that's Everest Base Camp on the Kumbu Glacier. And in 2019, when we were there for the climbing season, there were 1,000 people there, of which about 250 to 300 are trying to climb, and the rest are dealing with logistics, cooking, carrying gear. The people who climb Everest carry nothing at all. The porters put in, the Sherpas put in everything. I've worked with Sherpas forever. One of my students was the son of Norgay Tenzing. So I've gotten to know them fairly well. And there are TVs set up in some of these places. If you spend $40,000 on the expedition as an individual, you might make it up and down. If you spend $250,000, you're pretty much guaranteed because you have the best of everything. This is base camp at about 17,500 feet. It's just nothing but rubble on a glacier. Everywhere you go is constantly up and down. The terrain looks like something that's from World War I, from the bombing. This is the Kumbu Glacier in the middle. And as you see it rising through that small rock valley, that's the Kumbu Icefall. It's the most dangerous part of the ascent of Everest because that icefall is always moving. And as it gets warmer, as the climate gets warmer, there's going to be even more mobility in this ice. And if you, as my PhD student and my very close friend Mario did, and he was on the summit team, he went to a peak at night, took a picture of the base camp, and the lights that you see going up the icefall are people who are starting usually at about 2 in the morning with their headlamps to go up the icefall. And they go across ladders to cross the crevasses, ropes. It's roped the whole way, all done by what are called the Icefalls doctors. These are a group of really high-powered Sherpa climbers. This is what it looks like getting up onto some of the rock. There are ropes the whole way, but even so, you can obviously still fall. As you start to get higher and higher, you eventually go from 50% oxygen to about 40%. And at the summit, you're at about 30% of oxygen. This is the last camp before the ascent up to the top of Everest, which is that little puff of cloud, the highest part. And people typically spend one night here and try to make their ascent and then come back down again. You need perfect weather conditions, the right temperature, the right wind, and you want a high pressure system because the higher the pressure, the more oxygen you'll have, even if it's only a couple of percent. The red arrow shows you where Mario drilled the highest ice core in the world. I'll show you a picture in a second. And the yellow is where the highest automatic weather station was put in the world. So this is Mario in the middle, 26, almost 1,500 feet. Once you get up to this camp, you start wearing oxygen. The oxygen tanks are very hard to get up there. Sherpas can only carry a couple of them. One of them only lasts 4 hours if you're doing something really strenuous. So it's all about oxygen, how much oxygen you have and what the weather is like. If the weather was perfect and you had all the oxygen you needed, any healthy person could do it. But that's not the way it works. And this is the highest automatic weather station ever put in, obviously 27,500 feet. Below it is the second highest, also done by our summit team. And the purpose for this automatic weather station is to, for the first time ever, see what's going on in the level of the atmosphere that's just above ours, where the models really can't tell you what's going on. And it turns out that the data thus far over the last 2 years says that the models are actually not too bad. And that's very important, not only for understanding modern and future climate, but also for climbers to have real-time information up there. And the ice core, going back to that, the most amazing thing we learned here was that the surface of this glacier, it's called the South Col Glacier, was not snow. It has snow in the winter, but by the time the team was there, the snow was all sublimated, blown away. It exposed an ice surface. We were quite surprised when we drilled into that ice surface, sent it off to colleagues in Switzerland for carbon-14 dating, and the surface dates at 2,000 years. So 2,000 years of ice is missing from the highest glacier in the world. And we have a paper coming out in a few days now that show that 2,000 years of ice was lost in the last 20 years. So this glacier, which is only about 40 meters thick, will probably be gone in the next 20 to 30 years, and the landscape will look very different. We've been working in the Swiss-Italian Alps. There's the picture to the right. You can see that orange, that's the Saharan Dust. So we came up with a 2,000-year record of Saharan Dust events, which has a lot to do with fertilizing the Amazon and a variety of other things. But the other thing that we discovered, you can't read it quite, But as we drilled down and or I should say, as we analyzed using a whole new tool that we have created, we did lead measurements. Everybody has always believed that a safe level of lead is the level of lead that you find in the pre-industrial atmosphere, which can be measured with an ice core. So we now have a 2,000, that'll soon be a 4,000 year record of lead. And right at the time of the Black Death, which I think is 1346 or 48 to 1351, there is a tremendous drop down to almost zero of lead levels, which means that at that time, half the population of Europe died. So open pit mining for lead stopped, smelting of lead stopped, which was used for coins and a variety of other things because so many people died. So clearly the impact of a pandemic on one's economy, number one, but number two, in this particular case, even more important because everybody knew that it stopped the works, is the fact that the lowest measurement of lead that you find, one presumes, and we were able to prove it, is the natural level of lead in the atmosphere. So what we have been assuming is a healthy level of lead is in fact higher than that. And for the last 2,000 years, particularly in Europe, lead has been emitted into the atmosphere, doing all of the things that it does to people's health. So what's up for the future? We've been postponed, but as of, I hope this year, we'll be going to Greenland. That's the edge of the Greenland ice sheet. And the Greenland ice sheet, as we all know, is melting. As it's melting, all of this chemistry, toxic chemistry that has been trapped in it for hundreds, if not thousands of years, is melting out. And we want to set up a water quality monitoring system, which does not exist in Greenland, to provide a foundation for assessing how much it will change in the future because of not just melting, but because of open pit mining for rare earth metals, which gives off, in this case, uranium. And we can tell what the natural levels are because we have ice cores all over this area that tell us what the levels were a couple of thousand years ago. We'll also be going back to Chile, hopefully in April. Greenland is in June. And we're interested in Chile in a variety of places, but in particular because this is another water tower. And as you can see, that patch of ice is not very large, but probably 20, 30 years ago, it was a large glacier. And that large glacier stored water for hydroelectric power, for agriculture, and a variety of other things. So Chile is beginning to dry up. So I've had a wonderful time. I hope to continue for a while in the process, even when we weren't trying, because we went to places and had our eyes open. We managed to make some discoveries that hopefully will be valuable. We got to use a whole bunch of different ways of traveling, and I'll leave it at that. Thank you very much. So if you need to leave, please do. If you